Hello everyone, this is the first lesson recording for IM2, March 18th, 2021. Starting with announcements. Unit 8 tests will be during the next class as announced last lesson. It's going to be on solving quadratic equations and complex numbers and roots of quadratic functions. Also the rational exponents as well. So there will be 8 questions. There will be mostly free response questions. As you have noticed, we are making tests that's going to be difficult for you to use online solvers or other means of cheating. Or if you do, it's going to be pretty obvious for the teachers to be able to tell. So my point is, don't go there. Okay, make sure that you understand and you're prepared from your own skill, not relying on online solvers. So the Unit 8 core concepts that we've covered. You should be able to check if a number is a solution to a quadratic equation or not. You should be able to decide on any 3 methods to solve a one-variable quadratic equation. And that you should be able to identify a complex number and represent it using I. And that you should be able to find the roots of functions that are either algebraically or graphically. And that you can model situations as quadratic functions, explain the quadratic attributes in context, and solve the problem. And finally, that you should be able to convert fraction exponents to radicals. So what are we doing today? We are going to have 50 minutes of your choice. Okay, so your choices are, you can do guided review with me, or you can do independent review. The review packet is available for you. I am putting it out there, but I am not assigning it as homework. At this point, you need to figure out, do I need to do the review packet or not? I would say yes. And the last option is for those who would like to go farther because you feel pretty confident with the material so far. You're going to do independent study of extension, completing the square method. So to do that, I have a link. It's Khan Academy link. It's pretty good. Okay, so if you go to this link, it's going to get you started by watching this video, and then there are a whole lot more. There is completing the square video, worked out example, and then there are some practices and so on. I would like you to get started on this, and then if you are done, then you can certainly continue with more. Completing the square, like using quadratic formula, it works for every single quadratic equations. So it's pretty cool method, but it is a little complicated, and we are pushing it off to IM3 next year. So especially those students who are planning on doing IM3 STEM, this will be a good idea to get started on this. Alright, and then last 15 minutes we're going to get back together, and we're going to be working on some quadratic application problem and fractional exponent. Okay, so for those people who are working with me. Okay, so the first problem they're going to tackle is looking to see if you can check, how do you check if a number is a solution to a quadratic equation or not? Is x equal to 2 a solution to the equation 3x squared plus 7 is equal to 2x squared minus 4x? It's not asking you to solve. It's telling you that they found the solution. You just need to check if this is a solution. So what you should be thinking is, does the 2, x is equal to 2, make the equation work? So that's all you need to answer. That means that you are going to substitute x is equal to 2 into the original equation. Notice I said the original equation, not the modified, not the one that you converted into standard form or anything like that. You're checking it into original equation, so that means I'm going to start by writing the equation. 3x squared plus 7 is equal to 2x squared minus 4x. Okay, that is the case. Now we're checking for x is equal to 2. That means every time I see an x, I'm going to put in 2. Okay, notice I'm using the parentheses. This is going to be especially important when you're dealing with a negative number, because that is a very common error, is losing the negative sign. Okay, so then you need to use order of operation. Here we have to do exponents first before multiplication. So that means 2 squared. 2 squared is 4. 4 times 3 is 12. Plus 7 is on the left hand side. On the right hand side, what do I have? Negative 2 squared. That's 4 times 2 is 8. Minus negative 4 times negative 2 is positive 8. Okay, so you simplify left hand side. You just keep simplifying left hand side separately, and you keep simplifying the right hand side separately if it is not done so already. 12 plus 7 is 19, and on the right hand side 8 plus 8 is 16. Now, is 19 ever equal to 16? No, it's not. Okay, so it's not true. That means that x is equal to 2 is not a solution to this quadratic equation. Okay, now if you do get a statement that is true, like if the right hand side was also 19, 19 is equal to 19, that's true, right? That means that whatever the value that you substituted for, that is a solution to the equation. So that's how you know. Next up, the objective is that you can decide in any of the 3 methods to solve one variable quadratic equation. So you should be thinking about what are the 3 methods, what are the requirements or the restrictions of each method. So you should be very familiar with all 3 methods that we've covered. They all have application, the advantages and disadvantages, what you need, and so on and so forth. So make sure you are familiar. So zero product property, that's the factoring. Okay, what property are you relying on? You are relying on the fact zero product property, which says that if two things are equal to 0, if 2 factors multiply to 0, then at least one of them must be 0, or one or both of them must be 0. And what should the equation look like? You must get one side that is equal to 0, and the other side must be factorable or already factored. So like x plus 4 or x minus 4, it's already in factored form, or it is easily factorable. Square rooting, you're using the property that square rooting undoes squaring. And what does the equation look like before you can use this? You must get one side is equal to number, and the other side must only be something squared. Okay, so for example, x squared is equal to 24, or x plus 4 squared is equal to negative 30. So it can be positive or negative number, because now we know how to deal with complex number or the imaginary numbers as well, right? So it can be positive or negative because you can take square root of both positive and negative number. Then finally, the quadratic formula. What are we relying on? The formula. And to be able to use that, the equation must be in standard form, and the other side has to be equal to 0. So ax squared plus bx plus c is equal to 0. So for example, 3x squared plus 4x minus 7 is equal to 0. Okay, so let's think about this equation. Which method can be used, and what's the first step? Well, we have 3x squared plus 15 is equal to 0. Okay, so we can convert this very easily to something squared is equal to some number, because we are missing the x term, right? So we just have x squared here, so that means we're going to use the square rooting method. That's going to be far easier than quadratic formula. I know some of you just go straight to quadratic formula. That is going to be a lot more cumbersome, a lot more time consuming, and more error prone. Okay, so go with the one that is going to be easier and quicker. So to do this, we need to bring the constant to the other side. So we are going to bring positive 15 to the other side. How do I do that? You subtract 15. So then you get 3x squared is equal to negative 15. Then from here, I just want something squared on the left hand side. So what I need to do is I need to get rid of the 3. What is 3 doing to x squared? It's being multiplied, so we divide both sides by 3, and you're left with x squared is equal to 15 divided by 3 is 5, and negative divided by positive is negative. Okay, now from here, since I have just x squared, I can take a square root of both sides. But remember, when you take a square root of both sides, you need to put plus or minus. Some of you are in the habit of not putting this in at this point. You need to be doing this when you're taking the square root of both sides. Don't tell me the answers are both positive and negative at the end. You are missing a point when you do that, okay? So make sure you take a square, when you're taking a square root of both sides, you put plus and minus sign on the side with the constant, or at least one of the sides. Okay, so then the variable, the square and square rooting cancels out, and you're left with x is equal to plus or minus, what is square root of negative 5? That's same as square root of 5 times square root of negative 1, which is same as plus or minus square root of 5i. Okay, you can put I in front here or afterwards. That means I have my two solutions are my x could be equal to positive 5 root I, or x could be equal to negative 5 root I. What about this problem? X squared plus 3 is equal to 4x. Okay, this time we have an x term. Okay, that means we cannot use square rooting. So we have the choice between zero product and quadratic formula. Either way, I need to convert to standard form, which means that I need to bring the 4x to the other side by subtracting 4x, so that becomes x squared minus 4x plus 3 is equal to 0. Okay, now the coefficient in front of x squared is 1. That means at the very least you should be trying to factor it. This is the easy factoring problem. Okay, sometimes it's not going to work, but sometimes it is going to work, right? So you need to try. So that means I am going to put first by putting the x and x here. I'm looking for two numbers that multiply to 3, positive 3, but that add to negative 4. What are the factors of 3? That's just going to be 1 and 3. But to add to negative 4, they have to be both negative 3 and negative 1. Because when negative 3 times x is negative 3x, negative 1 times x is going to be negative 1x, and that's going to add to negative 4x. Okay, and so this is easily factorable. That means I have my two solutions. I have x minus 3 is equal to 0, and x minus 1 is equal to 0. Okay, so since it was easily factorable, we are using zero product and factoring. And then from here, I bring the negative 3 to the other side by adding 3, x is equal to 3, and x is equal to 1. Those are my two solutions. What about this? X plus 2 all squared is equal to 3. Okay, what do I have here? We have the whole thing squared is equal to some constant number. Okay, that means we can use square rooting. We have one side that is just something squared. Okay, so that means what do we do from here? We can take square root of both sides. So I'm just going to rewrite this. And what I can do is I can take a square root of both sides. And remember again, this is when you need to put plus or minus. Don't put the plus or minus as the final solution, because you're going to make some mistakes. You're making a conceptual error there. Okay, when you're taking a square root of both sides, when one of the sides has a variable x in it, then you need to consider that it could be positive or negative versions of it. So then the square and square rooting, they cancel each other out. So left hand side, you're left with x plus 2. On the right hand side, you're just left with positive or negative root 3. Okay, so then from here, I can separate this into two different solutions. So x plus 2 could be the positive root 3, or x plus 2 could be the negative root 3. Okay, please do write this, because some of you just sort of skip this stage and you make mistakes. Then from here, I am subtracting 2 from both sides.